When you guys walked in, I had this thing going right here on the board. Did you guys notice it when you walked in? So I had it going since 7:30 this morning, and then Google Chrome froze. So I had to like restart it as soon as you walked in. You guys notice a pattern? Where are most of the balls going? Middle. Kind of towards the middle, and then the least amount goes out to the side. This phenomenon is something that happens in real life when it comes to statistics. What's happening is, we call this the normal curve. It's called normal distribution. When you deal with large quantities, eventually what happens is they kind of sort themselves out into this pattern. This pattern is also referred to as the bell curve. The reason why I think is because, I mean, if you think of those old school bells, it looks kind of like one that's sitting with the handle straight up. When it first starts, it doesn't always start off using this pattern. But as the numbers get higher, then they always kind of go towards this. You guys remember the law of large numbers and probability? It's the same thing with this. So like if I was to hit restart, you'll see that in the beginning, it doesn't necessarily take on that shape that you were seeing, but it'll gradually build up until eventually it'll be that normal curve. Now once we start getting into the millions, because before I restarted it, it only had a couple thousand in there. But once we start getting into the millions, billions, and trillions, it'll actually be so close that it'll be perfectly smooth like you see in your notes. The paper that you have on your notes, or the picture you have in your notes, is exactly about this stuff right here. It's called normal distribution / the bell curve. Now it's called normal because that's what happens. It's normal for that type of pattern to happen when we talk about statistics. So a lot of things tie into it when we talk about averages and means. So I'm going to teach you how to read this stuff because that's what it all comes down to. The nice thing is you don't have to do a whole lot of calculating. At most, it's probably just like some adding of some percents. So why does this happen? Well, let me explain to you what this all means. The bigger amount is always in the center because you guys know about the average, right? The average is the number that's used to represent the entire group. That's why most of the things happen towards the middle, because that's what's average. It's common. As you move further away from the average, though, it's not that common. And I'll have some illustrations and stuff that I'm going to show you that's actually not in your notes to try to get you to see what I'm talking about. Now, every single curve that we look at when it comes to statistics has this center spot right here. This weird symbol, it's pronounced mu. It's a Greek symbol, but all you have to know is the average. So all of our comparisons that we're going to be doing are based off of the average. So if you want to write over this, I'm fine with that. I'm just going to say this is, I'm going to say this is the average. So all of our comparisons are based off of the average. Now you can see that these graphs, they get broken up into chunks. And so if I go one chunk to the right or one chunk to the left, that together makes up 64% of all my data. And it'll always work like that in a normal distribution graph. Now these chunks that I went to the right and to the left, that's called a standard deviation. I'm going to write that word. That's an important word in this statistics stuff. Standard deviation. In a real probability course where we go through the entire book, you would have to calculate the standard deviation because there is a mathematical way of calculating it, but we're not responsible for that. In this class, because we're only skimming the surface, we're going to tell you what the standard distribution is, or the standard deviation, sorry. So the reason I wrote it like that is because I want to tear it apart and think about, like, what the heck does it all mean? What does it mean to be standard? What does the word standard mean? What did you say? Yes. Standard is what's basically normal. Do you guys know what it means to deviate from something? Yeah, it means go away. So a standard deviation is what statistics calls the normal amount you go away from the average. So when we break the graph up into chunks, when I talk about a standard deviation, it's going to be the same amount every single time. And I'll show you an illustration here in a second, but let me tell you some properties of the normal distribution curve. So the curve is always bell-shaped. The highest point is always straight up above the average. It is also symmetrical. So if you notice, all the numbers to the right match all the numbers to the left. The thing that's interesting about this is because of the way this stuff all works, you can actually calculate the probability by using the percents that are underneath the curve. So if I could actually ask you probability questions, and you just have to read certain, like between a certain range, and then you'll be able to tell me the probability that that event would occur. The mean, the median, and the mode in these situations, or in this scenario, when you get this bell curve, they're always the same number. All three of them are going to be the same number. So down here at the bottom, it says the standard deviation is sigma, and it's used to quantify the amount of variation or dispersion of the set of data. So all that means is it's breaking it up into chunks across your graph. We want to see how everything is dispersed, so we want to see how everything is spread out. So the way we spread them out is by the standard deviation. The standard deviation is like a count that you're going to be taking in order to see, in order to break it up into the chunks that you need it to break up into. So I'm going to show you sort of how to interpret standard deviation and all of that stuff. Let me get rid of this for a second. By using this picture that we used in Algebra 1. It's a picture about dogs, and they give you all the information, except they broke this graphic up. Instead of looking like a bell curve, they kind of set up the standard deviation and the average vertically. So right here. And there's other parts to this. I just stole the part that I needed. This part right here is the average. So they calculated mathematically the heights of these dogs. They added them up and they divided it by 1, 2, 3, 5 dogs. And they found that the average is, I think it was like 4, no, I don't think I have it at the top. Actually, I don't have it, but it was like 397 or something like that. So remember I told you, we don't calculate the standard deviation in my class. They always tell it to you. So this is the standard deviation for these dogs. So what that means is if you break this graph up into chunks and count by 147 each time, that's the chunks that are going to give you those percents that you saw in the normal curve. So right here from the average, so watch this. Put this back. So right here from the average, if I go 147 up, that's that mark right there. So that's one standard deviation above the average. If I go 147 down, that's one standard deviation below the average. So basically what this is saying is we consider anything in between here to be normal. So these would be the normal sized dogs. Any dog in this graph that fits between those two lines is considered to be normal. If you were to go past that, that's when it becomes more rare. So anything past the line, so if I go above the line, and you can see the Rottweiler, the measurement of the Rottweiler is right here because they measure from the shoulders when they measure how tall dogs are. That Rottweiler is considered to be a large dog using statistics. So it's normal for a dog to fall in between these two blue lines. Anything above it is considered large. Anything below it is considered small. Now your standard deviation, because I told you earlier that there is a way to calculate it, we don't calculate it, we just use the information that they give us to talk about all the percents and stuff like that. So you're going to see that here in a second. But that's basically what normal distribution is. A normal distribution graph kind of shows us what's considered to be normal. So as long as you fall within certain boundaries, then that's considered to be normal. Anything outside the boundaries is considered to be rare. And that's why they happen less often. So I'm going to get rid of this picture real quick. And we're going to go back to this. So a lot of times I'm going to tell you the average is this and the standard deviation is this. So what we'll have to do is we'll have to draw our own graph and fill in our own numbers. Then I'll say what percentage of the population falls between these two numbers. So when I give you a range, all you got to do is tell me the percents after you have added them up. And I'm going to show you a couple of examples that here in a second. But here's what you need to know. If you go one standard deviation in either direction, because you can go one up or you can go one down, 68% of your data is going to land in between there. That's over half of your data. If you go 2 standard deviations, it jumps up to 95% of your data. So when I give you these boundaries and these numbers, 95% of your data is going to be those numbers. If I go up one more, look at how close it is to almost all of your data. And when I say data, I'm talking about those lists of numbers. Remember the ones we saw yesterday? What, 10 and 15 numbers in a list? What I'm telling you is, if I gave you 100 numbers, 99 of them are going to fall between whatever this number is and whatever this number is. So it gets very minute the further away you get from the average. So I'm going to show you how to do this now. You guys look at the examples on the next page. And there's something, it's called the empirical rule. Are those tests? Sweet. Thank you, sir. The empirical rule is that thing I was mentioning earlier where I said you can actually calculate the probability within a range of values and just read off the percents. That's all the empirical rule says. So watch this. This is how, we'll start to Montel Jordan. I was going to say, this is how we do it. Here we go. All of these problems, when it comes to standard deviation, have to do with this picture. So get used to it. I posted a picture of it in the back. So it says, a study was conducted to study the weights of high school wrestlers. It was found that the mean weight was 160 pounds. Guys, this part is probably the most important part because that becomes the exact center. It's 160. The second most important part is the standard deviation. The standard deviation tells us to break our graph up into chunks of 20 pounds. So that means the next line is going to be at 180. The next line after that is at 200. And then the next line after that is at 220. Now, standard deviation goes in both directions, though. You can go above the average, and you can also go below the average. So I'm going to make a line over here and say that this is 140, this is 120, and then this is 100. So they're asking us about a percentage. So here's what we do. All we got to do is kind of mark off the two numbers that they tell us, and then use the picture on the front page to see what those percentages are going to add up to. So it says, what percentage of the wrestlers would fall between 120, so from here, all the way up to 180, to here. So if you look at the chart that's on the back, the poster in the back that I posted up, this is 34, this is 34, what's the next one, 13.5? So all we have to do is add up those three numbers because it's between the boundaries that I set for you using the standard deviation. So 34 plus 34, what's that, 68? 68 plus 13.5, 81.5, right? So 81.5% of the wrestlers are going to land between those two weights. And that's how you use standard deviation to make those calculations. So I want to say it one more time, just a quick summary. And I don't care how you draw it. You can make them into the boxes and everything. I don't care. It's the same thing to me. A normal curve is what always happens with data. It gets broken down into these percentages based on the average and the amount that you go away from the average, which we call the standard deviation. It's the normal amount to go away from the middle. The standard deviation is always given to you. So if I could break this down into like the most simplest terms possible, the standard deviation just tells you what to count by. So if I tell you the standard deviation is 2, that means when you make your picture, count by 2s. That's all it means. Now, by doing that, we're actually forcing our data to break up into those percentages that never change. The first standard deviation should contain 68% of all of our data. So if I go one up, it's 34, and if I go one down, there's the other 34. Because these things are symmetrical. It does the same thing on both sides. So I'm going to show you that one more time, and I'm going to give you some time to practice on your own. So here's another one. Highway Patrol was conducting a study on the speed of drivers on a specific stretch of road. They found that the average speed was 68. That's the most important part because that sets the exact center of our picture. If you want, you can draw lines, I don't care. So this is 68 miles per hour. Now we need to figure out what the count line. That's where the standard deviation comes from. So they found that the average speed was 68 miles per hour, and the standard deviation was 5. So now I know how to break my graph up. I go 5 above 68, what is that, like 70, 73? And I go 5 above that, and that's 78. 5 above that, 83. And you don't need to go very far. Our standard deviation graph, the generic form, it only shows you 3 standard deviations to the right and 3 to the left. So this is what, 50, what are we doing, 5 miles? So 63. Thank you. Okay. 58. And then 53. So it says, what percentage of the drivers drove between 73 to 83? So that's the only that's the only part we care about. So 73 all the way to 83. And guys, for my test, for the chapter test, I'm going to have the poster in the back. For the hazing merit, you may have to memorize those percentages. So let's see what percentages we're looking at. The middle percent right here is 34. The one after it is 13.5. The one after that is like 2.4. The only 2 I have to count are these 2. So if I add those up, that's 15.9. So the average speed was 68, and only 15.9% of drivers drove above it between 73 and 83. Now, why is that? Probably because the speed limit is 75, right? You go faster than 75, now you're speeding, so less people go faster than 75. And that's about it, guys, on your homework, on the practice. It's going to ask you to do stuff like this. You just have to draw the picture, break it down. Sometimes, guys, they're going to ask you, they'll say, what is plus 1 standard deviation? So they're going to tell you what the standard deviation is, but they're going to have to tell you the average first. If I tell you that the standard deviation is 10, and I tell you the average is 50, and I ask you what's plus 1 standard deviation, you tell me 60. Yeah. And that's it. That's all I have for you today for this part of the statistics stuff.